Here is your topic 12-6, summarizing data and finding the best measure of center. So in this slide here, we have some important vocab that we might have heard before in class, but one of the words we mention is outlier. So an outlier is an extreme value with few data points located near it. When there is an outlier in the data, the median, I'm going to underline this, the median is the better choice than the mean to describe the center of the data. That's super duper important. If you have an outlier, it's going to skew your data. So if you have really great test scores like 100, 100, 100, 100, and then you get like a 40, that 40 is going to bring down your average, right? So if you were to say, hey, Ms. Limo, could I take the median of my data instead of the mean? Then I might say, you're really smart. Maybe we should. So if you have an outlier, then you might want to choose your data as your center of measure is your median instead of your mean, because an outlier will skew that data. So it says right here, when the mean is used, let me highlight here, the mean absolute deviation should be used to describe the variability. So the mean goes with the mean absolute deviation. Remember, mean and then mad. When I mean, I'm mad. And then we have, when the median is used, the interquartile range should be used to describe the measure of variability. So we'll talk about more of that, but if you're using the median, you'll want to use your interquartile range to describe how various your data is. How close together your spread is, your spread close together, or is it really spread apart? And then down here, just data distribution describes how data values are arranged. If the data set is symmetric, use the mean and the mean absolute deviation. If the data set is not symmetric, you're going to be using the median and the interquartile range to summarize it. So mean always goes with MAD, and the median is always with the interquartile range. So this screen right here, I have it in your online textbook as well. It's a key concept page that's out of your book. And it's just a really great page to take a picture of and have it nearby for your notes, or copy it down or print it out if you can. Once you take a picture of it, snip it out or put it in a Word document, something, because it mentions everything all together. So it talks about here, like the mean is with your MAD, the median's with the interquartile range, and then the mode over here is a good choice to describe the center of data if the data is not numerical. So if I were just to ask you about what's your favorite pet and you said dog, cat, fish, that's the type of data you would want to use for your mode, would be the best measure of center for that. So just an idea, and also gives us, what a box plot is down here, gives us what a dot plot is down here, and it kind of just explains it a little bit more in detail. So this would be a great page to print out or take a picture of and have on hand when you're doing this lesson. So here's our actual questions that we're going to be doing. And the first question we have says, the ages of 10 people who worked at a pizza shop are shown in the dot plot. What is the median, what's the mean, and which age is an outlier? So the first thing I would do is look at the dot plot, and I would write down those numbers that the dots are representing. So I just took all the data that was here. So there's 2 people who are 19 years old, 3 people who are 20 years old, 1 person's 21, and so on and so forth. So I listed all my data out onto just numerical order. So it asks us what the mean is. So to find the mean, remember, we just go left, right until we get to the middle value here. And we have 2 numbers in the middle, which means we got to find the average. So the average of 20 and 21 is 20 and a half, or 20.5. So that'd be my median. So to find my mean, I'm going to add all these numbers up and then divide it by however many numbers I have, which I know I have 10 numbers. So when I add all these up, I'm going to get 224. And and then I'm going to end up dividing it by 10, and 224 divided by 10 is 22.4. So that is my mean, 22.4. So it says which age is an outlier. So we know outlier is a point that is way far away from where most of the data is. So most of my data lies right here between the ages of 19 and 23. And then there's this one that's 38. So this 38 would be considered my outlier. So it says, how does the outlier affect the mean? Well, the outlier skews the data and makes the mean higher. So it makes my average higher, and it really doesn't give it a good picture of where most of my data lies. Most of my data, most of my kids' ages here, or most people in the pizza shop, are between 19 and 23 years old. Then there's a 38-year-old there as well. So way outside of the data. So what's the best measure of center? Well, if I should use my median, because I have an outlier, my best measure of center would be my median, because I'm just going to put a thing here that says because I have an outlier. If there was no outlier, then I would have just used my mean. So which measure of variability best describes the data? So because the median is the best measure of center, the IQR, the interquartile range, is the best measure of variability. Remember, they go together. So the IQR of the ages is blank minus blank. So we got to figure out the IQR. So my IQR is the upper quartile, or the third quartile, minus my lower quartile, or my first quartile. So where my median was right here between 20 and 21. So to find my lower quartile, I got to find the lower half, the middle of the lower half, which is 20. Remember this from box plots, I hope you do. And then let's look up here, and then the upper half would be 22 is my upper quartile. So 22 minus 20 is 2 years. So what this means is 50% of my data, or 50% of the people who work at this pizza shop, are only 2 years apart from each other. So 50% of the people who work in this pizza shop are 2 years away from each other. That's all that means. So this next question here has another dot plot, and the dot plot shows the number of grams of protein required each day for different diet plans. So we have, these different numbers here where it's 40, there's 2 at 42, 3 at 44, and so on. So it says most of the data points are grouped between blank grams and blank grams. So if you notice here, most of the data is grouped between 40 and 48 grams. And you can kind of see this guy right here is our outlier. But there's an outlier at, there's my question, at 56 grams. The median number of grams of protein required is blank grams. So to find my median, I need to list all my data out in order from least to greatest. So here's my numbers in order from least to greatest, and to find my median, I'm just going to start crossing off left, right, left, right, left, right, and there's my center. Both my numbers in the middle here are 44, which means my median would be 44 grams. So that's all I had to do for that first question. Down here it's giving me a box plot. It says the data distribution of museum visitors. So it's asking about the number of visitors. So use quartiles to describe the data distribution. So quartile 1 is the lower quartile right here, and that would be 120. Quartile 3, I'm going to use a different color here. Quartile 3 is my upper quartile, which is 180. And then quartile 2, we don't really call it quartile 2 that often, but that's your median. So your median is actually called quartile 2, and that's at 160. So it says circle the words to correctly describe the shape and the data distribution. So the quartiles are or are not equal in size. So if you look here, this line right here is a lot longer than this one right here. So are they the same size? No. So they're not equal in size. So if they're not equal in size, are they going to be symmetric? No. Symmetric means kind of like a mirror image or a copy of one thing to the next. So it's not symmetric. So the data values are more spread out to the left or the right. So if we notice over here, these are more spread out on the left side than on the right side. So the left is more spread out. So then it says find the interquartile range to describe the data distribution. So the interquartile range, remember, is the quartile 3 minus the quartile 1. So we have 180 minus 120, and that gives us 60. So 50% of the data is between 60 visitors is what this is talking about. Okay, so that is it, guys. So I will have another video that is going to help you with some of the Math Excel questions that are going to be coming up. So I will have 2 videos for this section, and the Math Excel can be a little tricky this time because it's wordy. So make sure to be listening. You definitely want to watch all of this, all of these videos I give you, and take some notes. Take some pictures of this if you need to, so you can have it on hand when you're taking your quiz.